Okay, so chapter 7, statics. Is my voice clear, students?
Yes, sir.
Thank you. So in this chapter, so three main areas, 7.1, 7.2, 7.3, center of gravity, something that is very important, even though it's not important for the exam. Okay, so but then when I talk about in our life, so center of gravity plays a very important role in providing a stability for an object, not matter it is a living thing or you can refer to the objects, vehicle, and so on. Design of a car, design, all that has to take consider about the center of gravity. Okay, so for the stability and for certain limitation of speed and taking curve, all that has to be calculated based on center of gravity. Okay, then we have 7.2, equilibrium of particle. So how a system, it can be referring to a body, a mass, or we can refer to a point, a particle, how it can be in equilibrium. And final, equilibrium of a rigid body. So we are referring to a particular object. So if it is going to be equilibrium, the term equilibrium is referring to an object to be in a way we will say the resultant, the net force is basically zero. But over here, when you say the equilibrium of a rigid body, okay, so then in a way we are referring to a body brought to a situation of rest. Okay, so this is according to the syllabus. The expected candidate should be able to understand the center of gravity and able to define the center of gravity, state the condition with which the center of gravity is the center, state the condition in which the center of mass is the center of gravity. So you have COM and COG. Okay, so center of mass and center of gravity. So what is the difference between them, if there is? Equilibrium of particle, state the condition for system to be in equilibrium. So there is generally two conditions for system to be in equilibrium. If you have done the chapter, then you should be able to recall. There is only two conditions for system to be in equilibrium. Solve problems involving forces in equilibrium. So then it is more to solving problem calculation, quantitative. So by trying to obtain an equation, and from there you will solve problems to find the unknown forces which is required for the system to be in equilibrium. Done. So then go to 7.3, equilibrium of rigid body. Okay, so over here we have some new things you will learn. So one of it is if we call as a torque. Okay, so torque is a turning effect experienced by an object. So the formula for the torque, it is the force, product of the force and perpendicular distance from the pivot. Okay, so product of the force and perpendicular distance from the pivot. For example, if I have an object, this is the point of where it is pivot, and at one end I apply a force to cause it to rotate. So the perpendicular distance between the point, yes. Okay, so perpendicular distance between the force, this is the force applied, and the point where it is being pivoted, R. So if the force is perpendicular distance, they are perpendicular to each other, then I can just take the R multiplied by the force. That gives me the torque. So what we understand, torque is actually a form of turning effect. So around us, you can find a lot of examples which can be related to the turning effect. So one of the example is when you open a door, when you close the door. So the door have a hinge to the wall. when you hold the knob is one end of the door. The hinge, okay, the hinge, okay, if I draw a door. So this is the door frame, okay, so then you have a door here. This is the frame. Okay, so the door will be basically like hinged to the wall. So the knob is here. So you will open and close. So the force is applied here. But then this is the point where the door is pivoted. So you have a distance from the door to the point we apply the force, which is going to cause the turning effect. Okay, so there is a condition, state the conditions for the equilibrium of a rigid body. Okay, so again, it goes back to the point to discuss these two conditions. Sketch and label the forces which acts on a particle and the rigid body. So that one is depending on the situation. So in a way, it is referring to the free body diagram, which we have discussed this before. Free body diagram, which is able to show the forces acting on a system. Then use the triangle of forces to represent the forces in an equilibrium. So in this case, you have, this is something related to what you learned before earlier. So you have something called polygon of vectors. Have you all heard about this? Polygon of vectors? Anyone, this is first time hearing polygon of vectors. So when you say polygon of vectors, mean if you have more than two component of forces. Because if you have two components, it will lead to a triangle. So, but if you have more than 2, 3, 4, it will give you a polygon. So like you have vector A followed by vector B followed by vector C. Okay, so then the resultant will be from A to C here. So this is the resultant vector, which can be also written as A followed by B followed by C. I can take A plus B plus C. Okay, so that's this is known as the polygon of vector, not triangle. Then solve problem involving. So a lot of things is basically understanding the idea of the system to be in equilibrium and apply that into solving problem. Okay, so statics. Okay, so understand statics equilibrium is the state where forces are in balance. So the total force acting upward. So if I say, if I have an object, if the total force acting upward is balanced by so if the total force acting upward is balanced by the okay, so you have the weight. So it is balanced by the reaction force upward. So in that case, vertically there is no net force balance. If the object is not moving in any direction, it is rest, meaning whatever force, the force acting to the right is equivalent to the force acting to the left. For example, if there is no force acting to the right, means there is no force acting to the left. So there is no force, no friction. If there is a force, there will be a friction. Okay, so if there is the surface is rough enough to provide a frictional force. So that's why we say balanced forces acting on a rigid body or a particle so that it remains in rest. So that is the static equilibrium. The system is in a rest where the forces are balances each other. So first thing is to look into center of mass or center of gravity. You try to balance this. Okay, so may any object. So you can balance it if you really support the object at the center of gravity or center of mass. I can take a meter rule. If you take a meter rule, I'll ask you all a question. If you take a meter rule, and if this meter rule is 30 centimeter one, the one 30 centimeter, if you try to balance it, where do you think the center of mass is? Students? At 15. Yes. Okay, at 15. Why 15? Huh? Can it be at any other point like 14, 16, 17, 18? Falls in any good number according to the feng shui of the ruler? Why it must be at 15? What is the key thing, key word in the question? Because 15 is the midpoint of the 30 centimeter meter rule. So what is the keyword you will find in a question which explains that the center of gravity exactly at the midpoint? What is the keyword they use in the question? Oh, sorry, they use in the question. Yes, students? What's the keyword? Indicates the center of gravity it is at the midpoint of an object. In case if you are referring to a meter rule. So when I refer to a meter rule, okay. So how do I come to a conclusion? Okay, exactly at the center I have the center of gravity or center of mass. How? What is the keyword? Will tell you the weight or the mass is exactly at the meter point, the center of mass or center of gravity. Why no answer? Center point. No. They will not tell you center point. They use another word. And from that word, you have to then predict it has to be at the center point. They will not tell you it is center point. They use another term to give you that information indirectly. Equilibrium, no. Equilibrium means the system is in rest. Okay, so balance. But that didn't mean, that didn't, that did not confirms that the center of mass has to be exactly at the midpoint. All the forces act at the same point. That is the definition for the center of mass. So my question is, what is the word in the question indirectly tells you the center of mass is exactly at the midpoint? So the word is uniform rule or uniform rod. So the moment they say it is a uniform object or uniform rule or uniform rod or anything, so then indirectly they are trying to say the center of mass is exactly at the midpoint. Eventually you will notice center of mass and center of gravity is the same. Center of mass means m. Center of gravity means the mass multiplied by the acceleration due to the gravity g. So that will be mg. Okay. So the center of mass defined based on the formula, all the forces acting at the point, or you can say center of mass is the point where the entire, okay, so this is also defined as point where the entire mass or weight of the object is considered to act. Okay, so I think Eventually, you notice that center of mass and center of gravity is the same. Okay, so we just center of mass is just based on the mass. Center of gravity, it is the product of mass and acceleration due to the gravity. So this is a simple way of trying to identify the center of mass. So if I take an object, uneven shaped object here, over here there's only 5 points or coordinates which has been labeled. But in a real situation, it's not only going to be 5, it will be more than 5. Every single point will have a coordinate of x and y. So if I want to find the center of mass, what I will do? Okay, so look at object, put it in a coordinate. So we need to know the coordinate. So once you have relate to a coordinate scale, then I can actually find the coordinate values for x and y. So just say, for example, my x1 and y1. Well, I mean x1, y1. The distance, okay, x1. So this is, you'll have the x1, but then I must take what is the mass at this particular point. So I will take that mass, multiply by x1, plus the mass multiplied by x3, plus the mass multiplied by x2, okay, plus multiply by xn. Okay, so in that case, you will have a total mass of that particular point. Okay, anyone have anything to say? No, huh? Can you all follow? Are you all following me? Are you all following me? Is that sleepy? Because this is the time sometimes you may feel sleepy. Yes, sir. Yes, sir. Mean what? Following me or sleepy? So I asked 2 questions. So yes is for which question? Okay, good. So wake up. Okay. So yeah. So you take the mass at a particular point, then you multiply by the distance. So that will. So you need to repeat that for all the x coordinates. Then done. You get the total of the mass of each particle multiplied by their distance corresponding to the position of the points on the object. Fine. Then divided by the total mass. Then done. That is already give you the for the mean for x. Then move on to your y. Do the same thing. So you take the distance y1 times the mass of that particular point m1 plus y2 times m2 plus y3 times m3. Okay, so go up. So add all, divide by the total mass. Basically, the total mass is going to be the same because you are referring to the same object. So you divide. So you get the mean. And the total mass here, because you're finding the total mass of your m1 plus m2 plus m3 plus m4. So they will have you will have more. Okay, so basically it's every single point of the object. So eventually that will give you the total mass of the object. So you are going to divide by the total mass of the object. So that gives you the mean for x and mean for y. Finish. And by the way, so it's already indicated. Capital M is a symbol we use for the total sum of all the masses, which is the total mass of the object. Okay, fine. Okay, so if you understand, okay, try to do this. See who can get the answer. One more, wait. Very simple question. Try. So once you get the answer, you can see you can get the answer. But don't worry, in the exam, they won't ask you this question. I don't think so they will ask. So this is just for your practice. But then maybe in MCQ question, they can ask you. So by the way, just give me 1 minute. So just give me 1 minute. When we get something. Okay. So Varsha, yes. So the answer is correct. Others, I only can see one person give me the answer. How about others? So 3.29, that is for the X, and 1.76, that is for the Y. And if you see here, okay, you need to be careful also. If you look at the coordinates here, yeah, so 3.3, 1.8. Okay, so this I'm going to talk about. So if you look at the location coordinates that is given, so if you convert the gram, okay, so to kg, okay, so when you convert into the kg, then it's going to be 0.030. So that will work out to two significant figure. Okay, so that will work out to two significant figure. So therefore, in that case, the even when you talk about the distance, so this is based on 5 centimeter, 7 centimeter. Okay, so but then did not matter over there. Okay, so if you're looking at the mass when it change, so you have two significant figure. So therefore, the final answer, so we will prefer to leave it as two significant figure, which is 3.3 or 1.8. So that is following the a rule. Okay, so we call it as a rule of thumb. Okay, so otherwise, fine. So I suppose all can get the idea how to solve them. So you have your, oops, sorry. So here you have your x dash y dash equals to. So then you have to calculate for the all your x and all your y. So for x, so you have 0 for a, for example. So it is, so here you have a, b, c. So a is 30 gram. Your b is 60 gram. And the c is 80 gram. So therefore, the distance here is basically 0, but the mass is 30 gram. So I will take 0.030 times 0 plus, so this is also, okay, so 0.030 60 times 0, because the distance, the x is basically 0 here. So the only one is 80, it is 7 centimeters away. So I will take z plus 0.080 times 7. Okay, fine. You divide this by 0.030 plus 0.060 plus 0.08, sorry, 80. Yes, done. So this gives you for your x. So you do the same thing for y, referring to the coordinate of y multiplied by the mass. So only one, okay, for y, because it is going to be only the second coordinate b will have a value for y. The other two, a and b, are at 0. Okay, so that's how eventually when you solve, you'll end up getting 0.56 over 0.170, 0.3 divided by 0.170. So when you simplify, you should get the value as 3.3 and 1.8. That will be the final answer. Okay, I think no need to further explain. Okay, you're fine. Then, how experimentally we can determine the center of gravity? So to determine the center of gravity, so we have an experiment can be conducted. The experiment like this, which is called the plumb line method. So plumb line method. So plumb line method is the way, a technique that is adopted to determine the center of gravity, or center of, you can also center of mass of an object. So to do that, an imaginary point at which the entire weight of the body seems to act. That's a definition for center of gravity. So it's the imaginary point, or you can say it is the point where the, or you can say a point, how do you put it? Okay, so you can say point where the entire weight of the object is considered to act. So point where the entire weight of the object, sorry, oops, considered to act. So when you do a plumb line method, so now I'm not sure whether you have this in SPM or what. You can do it at home lah. You can do just a simple experiment. You can do it at home. You can take a cardboard, so any cardboard, or you can take a box, some box, the box cut. You cut it to a uneven shape. Then you need a pin, any kind of pin, a string, and a weight. Not necessary as to be a pendulum. So it can be any weight. You can also use a key, your house key. Please don't lose the house key lah. Okay, then your parents will be chasing after you. So use a key, then hang it. So you poke the pin through the cut at any part is fine. Just poke through. Make sure the pin does not like have too much of friction with the cut. So the hole must be large enough so that the object when it hangs, okay, so the pin does not experience much friction with the cut. So it is like free. So let it to hang freely. Then you see. So it cuts straight through. Mark 2 points. Okay, after marking 2 points, change the position of pivot. Rotate the cut, different point. Then mark another 2 points. So first one, you already draw a line. Second one, oops, sorry. Second one, you draw a line again. Then you see the previous one and this one. So the line will intersect at one point. If you want, you can do the third time. So you can do on the other side. So you will still find that if everything is fine, everything is correct, you will notice all the three lines will pass through one point. It will coincide at one point. That is the point which is known as the center of gravity. Okay, this is using the plumb line method. Okay, then not a problem. You don't need to explain much on that. Go on. So if you want to find the center of gravity, easy. You just have to multiply. The formula is the same. You just have to multiply by the g. You look at the g here. So you have g here, you have a g here, you have a g here, you have g here. So you need to multiply g. But then, if you try to further derive, here also I multiply by g. Here also I multiply by the same g value. Cancel, cancel. Eventually, you notice that it comes back to the same formula, center of mass. So the conclusion here is the center of mass. Okay, conclusion. C. Oops. Conclusion. COM is equivalent to COG. Center of mass is equivalent to center of gravity. Okay, good. So we are going to, that's it for the center of mass, center of gravity. I'm not going to drag too much on that. No point. Okay, so next we are going to equilibrium of particle and rigid body. Any question, students? Any question, students? No. Okay, good. Thank you. Come. Rigid body. Equilibrium of particle. So when you talk about rigid body, first thing you look at the equilibrium of particle. So assuming this particular particle that you see here, okay, the particle that you found here, it is in equilibrium. So how is the condition? How I can come to a conclusion saying that it is in equilibrium? When in equilibrium, what need to be satisfied? So here, when they are in equilibrium, you must understand the net force, the resultant force here must be zero. So whatever the net force acting on the system has to be zero. So meaning my take F1 plus F2 plus F3 is equal to zero. I can also show this in a vector diagram. If I were to show this in a vector diagram, so okay, so for the vector diagram, so just say start with 1. Okay, never mind. I'll start vector 1. Then once it ends here, I will start with vector 2. So vector 2 goes, it should be parallel, I draw. Okay, sorry. Okay, this is F2. Which is here. Then once it ends here, it will follow your F3. So now you notice vector 1, this is F1, vector 2, vector 3, they are basically going in the same direction, which is the anti-clockwise. And if they say it started at this point, it returns back to that point. So that indicates it is a closed triangle. If you remember, I did mention this before. So when you get a closed triangle, means there is no net force on the system because it comes back to the same point. So there is no resultant. So this is based on the diagram we can see. But then in terms of formula, that's the understanding. So the net force is equivalent to 0. Okay, but how do we further? Okay, because it's quite difficult for us to solve it. Okay, by taking, okay, oh, I can like this f1 plus f2 plus f3 equals to 0. So because you may not know the values for f1, f2, you may know the angle. So in that case, you are not able to solve the problem unless you break it up to a x component and y component like this. Okay. So for example, now, when it is in equilibrium, I must understand horizontally, there should be no resultant force. Okay, there should not be resultant force in horizontal, meaning the resultant, the total force in direction of x should be 0, and the total force in the direction of y also must be 0. So there should not be a net force in x direction, net force in y direction. If there is no net force in the x direction and y direction, what will happen? So no force along the x, no force along the y. So the object will remains equilibrium. So that is one of the conditions. No resultant force. Okay, so here is no resultant force. So how do we solve this problem? First, look at the horizontal x. So in horizontal, up to me, I can choose the forces acting to the right as positive, and the forces to the left, I can take it as negative. So the only force acting to the right is F1. So I'll put F1 plus my F2 is acting at an angle of alpha from the vertical. So if I resolve the F2 to horizontal, then it will be acting in the direction to the left. So left, I take negative. So it will be negative F2. So since I'm using the alpha as the angle of reference, which is from the vertical, then I have to resolve sine alpha. If I use the angle here, then it will refer to cos. For example, if alpha is 30 degrees, then the balance angle here has to be 60 degrees, because we know that total angle value for the right angle is 90 degrees. So if you take 30 out from 60, so the remaining 30 from 90, you get 60 remaining. So but it's up to you whether you want to use 60 or 30. So over here, sine alpha means we are referring to the alpha, which is 30, plus even beta also, if I resolve to the left, it is in the negative direction. So I will take negative F3 sine beta. So when I plus all this, or in a way F1 minus this F2 and F3, which is resolved, that should give you the resultant of x. The resultant for the x direction, which is 0. Then you do for y. So y also, they should not be resultant, meaning whatever the force acting upward must be equivalent to the force acting downward. The force acting upward will be F2 cos alpha. The force acting downward, when you resolve, it will be plus. So if up I take as positive, down I take as negative. So it will be negative F3 cos beta equals to 0. Finish. Are you all following me, students? Is that okay? Okay, thank you. How about Taniyong? I suppose just now Kirtana joined. Okay, so okay, so now only you can see only 1, 2, 3, 4 people. Okay, fine. Moving on next. Okay. So yes, question. So we already discussed this. If you are clear, then you should be able to tackle this. So from this, then we will go into a more complicated situation. So this is just referring to the particle. Okay, try. And there's a possibilities of this type of questions to be asked in MCQ and also in a short structure. Okay, now try this question. Follow the steps I mentioned. You have to find the resultant, mean you have to get the term for the resultant for X and resultant for Y. So what is the time now? So the time is 47. Okay. So 5 minutes. Take a 5 minutes here. So probably we'll see all. Okay. So I'll see you all 53. So now 47. So 53. 353. Okay, 9 Newton and 15 Newton. How about others? I can only see one person get me the answer. You shall work it through, then you'll see. Anyone else answer? Okay, so as follow what I mentioned earlier, find the, so figure below shows 3 coplanar forces. Coplanar is a term used when you are referring to a system or a body when it experiences more than 2 forces. So that's why we call that as the coplanar forces, acting at a point so that the point is kept in equilibrium. Find the value of P and Q. Okay. So in order to solve, so first as I say, I find the resultant for my X. So the resultant for X has to be 0. So now for X, the force that is acting to the right is Q. So when I resolve, then this will give me Q cos 30 degrees. So I have Q cos 30 degrees plus, if I resolve 12, that's going to act to the left, which is negative. So I will put it as minus 12 cos 60 degrees. Therefore, my Q cos 30 degrees is equivalent to, I've moved this, oh sorry, this is supposed to be equivalent to 0. Okay, I didn't write equal to 0. So therefore, if I move this over, then I will have 12 cos 60 degrees. So my Q will be equivalent to 12 cos 60 degrees divided by cos 30 degrees. So you'll get your answer for Q. What was the answer? Cos 60 divided by cos 30. So 0.577, I multiply by 12. So I get 6.9. Okay, so just now what was the answer? Given 9. How come you get 9? Okay, Roshan. So it should be, based on my calculation, it should end up 6.9 Newton. Okay. Okay, students. Then we'll go for Y. So this is for your X. So the resultant for the Y also must be equivalent to 0. So now okay, so you try to draw a vector diagram. So you solve by scale drawing, is it? What then? By scale drawing will be a bit of difficult. Whatever I mean, you did drawing. Okay, maybe the drawing causes some error. So if you use your calculation method like this, you'll get a more accurate value. Okay, so I will suggest, unless the question asks you to use your drawing, okay, so then you use the drawing, but I don't think so. STPM, they will ask you that. So STPM is more of solving using the understanding of the resultant on the x and y to be 0. So you use the condition of resultant force, or the condition of resultant force equals to 0 to solve the problem. Okay, next. So do the same way. So resolve for the vertical. So when I resolve for the vertical, the only force that is acting downward is P. The other two forces are, when I resolve, is going to act upward. So just say I'll take 12. Okay, so 12. When I resolve to the vertical, so it is going to be 12 sine 60. Okay, so I have 12 sine 60 degrees plus Q sine 30 degrees. Okay, this is acting downward. So if upward I take positive, downward I must take negative. So plus negative P equals to 0. Therefore, negative P I move forward, then I will have P equals to 12 sine 60 degrees plus Q, I already know, it is 6.9 sine 30 degrees. So now you solve and see, you'll get your answer. So that should be 14 now. Okay, so if no wrong, so that should be 14 Newton. Got it? So that will be, should be the answer. Okay. Next. Any question? Okay, no, huh? Next. This is going to be a more challenging. So this is a more overall question. Okay, so which you are going to experience. Okay, so this is nothing. Don't get confused with this. Okay, so all. Okay. Come. Okay, read the question first, students. This will challenge your understanding. Just now is my, now is going to be, this is more like an exam type of question. You can start working a block of weight. Okay, so you have a block of weight 100 Newton is on a smooth plane inclined at and 30.0 degrees to the horizontal. Calculate the values of R1 and F1 when the block is in equilibrium. So when the block is in equilibrium, as shown in figure 1. Okay, then B, the horizontal force F2 required to keep the block in equilibrium, and R2 as shown in figure 2. So here you have horizontal force required to keep the block in equilibrium. So both in a situation, okay, so you're talking about how to keep the block in equilibrium. Over here, the force is applied in this particular direction, which is a line parallel to the plane. Over here, the force F2 is applied on the object, it is acted this way. So there is a lot of difference. This is applied on, this is like pushing it, this is like pulling it. And also the direction is actually different. So that's going to cause the difference in the magnitude of the forces. Okay, you can start first. So you must do so that you know what concept you are getting it wrong. Okay, so in case if you are getting it wrong, if you are getting it correct, fine, good. So if you do it, okay, so when you get some wrong, so then you know where you made the mistake, and you know, okay, how is next, also what is the better way to approach the question. So think first. So I'll just give you about 3 minutes. You need to recall the things that you learn in kinematics a bit. When there is a friction, you must know frictional force. So by the way, okay, sorry, in here we don't have the friction because the question already mentioned it is the smooth plane, sorry. So, but then you must understand that the force when it's applied, so that can cause a change in the normal force. So you need to do some calculation to find the normal force. Okay, so R1 is 86.6 and F1 is 50. Okay, correct? Okay, correct. Okay, so good. Roshan Varsha. Then B force is 57.7. Yes. What about the R2? Okay, so we shall see. So for the diagram one, okay, so for the diagram one, we'll use the thinner. Okay. R2 equals to R1. Yes, sir. No, cannot be. R2 and R1 cannot be same because here the force is acting parallel, but over here the force is acting like on. So when I resolve my F2, the F2 is basically like acting downward. So this will be when you resolve. So if this is 30 theta, 30 degrees. So when I resolve, okay, so this will be F2 sine 30 degrees. So my F2 sine 30 degrees plus R2, sorry, F2 sine 30 degrees plus my mg, which is 100 cos 30 degrees, that will give me the R. So your R will be actually greater. Over here, your R is just going to be 100 cos 30 degrees, right? Cos 30 degrees, okay, so you have 8, 6, okay, that's it. But over here, this force is acting on the object. If you remember, we discussed this in the part kinematics, dynamics part. Kinematics, dynamics. So we have discussed about this. So when a force is applied on the object or applied on or away, so there will be an effect on the normal force. So when a force is applied, it will increase the normal force. Okay, we'll come back to continue first. So here when it's equilibrium, okay, so the force F1 will be balanced by the, okay, so the only force here is going to pull the object down is the component of the weight of the object, that is mg sine 30 degrees. So my F1, which is acting upward, if I take that as positive, plus mg is opposing, so that will be negative 100 because my mg is 100 sine 30 degrees equals to, so because it is in equilibrium, I'm expecting it to be 0 lah. So therefore my F1 is equivalent to 100 sine 30 degrees. So that will give me 50 Newton. Okay, fine. Then for the R, so we understand that the R1 should be equivalent to 100 cos 30 degrees. So therefore, it is just cos 30 is 0.8660. Okay, so define 100 as 86.6 Newton. Okay, right. So what about here? When talk about the, which one I should find first? So my F1, when I resolve, this will be F2 cos 30 degrees. So the only force that is going to oppose this is the mg sine theta. Okay, so I will put it as, okay, where I can find the space. Okay, so I will do this over here. This is for A. So I'll do the B above. Okay, so for B, when I write the equation, my F2 cos 30 degrees plus minus 100 sine 30 degrees equals to 0. So that's it. So therefore, my F2 will be equivalent to, this one move over, I have 100 sine 30 degrees divided by cos 30 degrees. So 0.5 divided by 0.86. Okay, so I think when you work out that, you should be able to get the answer 57.7 Newton. Done. And then So the R part. So you must understand R is equivalent to, if I see the object, so I have the R2, but then I have the component of mg cos theta. Okay, so and then plus, I erase it, otherwise it may. So I have the R2. So this is 100 cos 30 degrees plus F2 sine 30 degrees. Okay, so this is the two forces acting downward. This is the only force that is acting upward. So according to that, if I write the equation, so my R2 plus minus 100 cos 30 degrees plus minus F2 sine 30 degrees equals to 0. So then eventually you will able to get your R is equivalent to, so this one, okay, so bring, so that will get mixed up. So R should be, what is the R value? Okay, at least the last one you have complete. What's the R value in this case? Is that same as the R1, which was 86.6? Can you please calculate this value for R2? Come on, students. Yes, students. Correct. So I have 1115 Newton. Okay, anyway, I'll just write the answer here. Thank you, Tan Hong. So for the first one, your answer should be my F1 equals to 50.0 Newton and my R1 is equivalent to 86.6 Newton. And for F2, it is equivalent to 57.7 Newton, and R2 equals to 115 Newton. Okay, got it. Yes. Go on to next. So this to make a conclusion about what we have discussed. So when you are looking at a body equilibrium of a rigid body, condition 1 for system to be in equilibrium. So if I say a body it is in equilibrium, the first condition is zero resultant force. So the force has to be resultant force. Okay, so the resultant force has to be 0. So in any direction. So but usually we will resolve it to the x direction and to the y direction. That's why we have the horizontal and the vertical. Okay. So then it comes to the next second condition. So the second condition part. Okay, so probably. Okay, so otherwise that's going to like end anyway. So see, because whether I'm thinking whether that should continue on the next session or not. Never mind. We'll explain first. So there's two conditions for system to be in equilibrium. The first condition, the resultant force has to be zero. The second condition, we are introducing a term called torque. Okay, turning effect. Okay, so which is understood as the turning effect. So a turning torque is equivalent to, as I mentioned earlier, it is the distance, perpendicular distance, multiplied by the force that is applied. So maybe you'll see a lot of examples later. A condition, so that's the condition 2. Resultant, zero resultant torque. So there should not be a resultant. So for example, okay, just say I have a a door maybe. So a trap door, they call it as a trap door. Okay, so the trap door, so this is being the pivot point. So if just say the trap door, it is uniform. So meaning at the center of the trap door, there will be weight of the trap door acting. So, and if it is a uniform rod, then I'm expecting it has to be at the midpoint. The total length of the door is just say L. That is the total length of the door. Okay. And at one end here, and exactly at the end here, a force or maybe a string is tight. So it produces a tensional force that is acting upward. Okay. So since the weight is acting at the midpoint, then this has to be L over 2. So you will notice that the tension is acting upward. So since the tension is acting upward, it is going to cause a turning effect because this is a pivot, so it's going to cause a turning effect in this particular direction. Whereas your weight is going to cause a turning effect in this direction. So this is known as the anti-clockwise. And this is the clockwise. So this is turning effect in a clockwise. This is turning effect in anti-clockwise. So if just say the resultant torque, which is the product of the weight, perpendicular distance, is equivalent to the product of the tension and its perpendicular distance from the pivot. Okay, so if the system is in equilibrium, if there is the resultant torque is zero, then they must be same. So they will be same in this case. So you can solve the problem to find whatever the unknown. So this is the idea of zero resultant torque. So the total turning effect cost on an object will be zero. So meaning the total turning effect in a clockwise should be equivalent to the anti-clockwise. So taking a moment at any point. So moment is also referred as the torque. Okay, so at a point of a rigid body, in other words, make the point a rotational axis. So we refer this as a rotational axis. So conversion. So when we are referring to a clockwise direction, that will be taken as a negative. When you are rotating in a anti-clockwise, we take it as a positive direction. Any idea why? Why clockwise we take negative and anti-clockwise we take it as a positive? Any logical answer for that? Supposedly clockwise should be positive, anti-clockwise should be negative. Correct or not? Because that's the clockwise one. But why anti-clockwise is taken as positive? Anyone? Your teacher mentioned to you? No one. Anti-clockwise is upwards direction. What do you mean by upwards direction? What is upward? So anti-clockwise, upward direction. So not, I could not relate what you are referring to upward direction. Any idea? Any other logical point? There's only one point now, okay, logical point. So what is that point which is used to indicate anti-clockwise as a positive direction and clockwise as a negative direction? Yes, students? Can you? Varsha? Praveen? You have been quiet today. Praveen, are you there? Oh, so left already. Okay, so since no one want to answer, okay, so I will give you the answer. So the logical explanation for why anti-clockwise taken as positive is that's the direction you turn anything that you want to loosen. Even or just open your water bottle or any soft drink bottle. When you open in anti-clockwise direction, that is opening, positive. Anti-clockwise, okay, anti-clockwise is opening. Clockwise, you are actually tightening, that is negative. So loosening is called, it is taken as a positive direction, and tightening it is taken as a negative direction. Got it? So that's the logical explanation for that. Okay, done. So finish on the discussion about a torque. So the second condition which is required for a system to be a equilibrium. So over here, okay, so you will have some questions to further look into. Okay, so I will, this one I will, when I do the discussion, okay, so in the class, I will post the questions to discuss. So you have to hold on with this, okay, questions. Okay, so this one you can try. Okay, if you want, you can give a try first. So then you have some exercise questions for trying. So you can try 1, 2, 3, 4, and then you have a structure question. Okay, so generally, okay, so the idea for the chapter, okay, so it is already taught, but then towards the end, I will add when I see you in Wednesday class, I will add few more things, okay, to explain about how when friction comes in, how the stability of the system or the direction of the forces will change. Example, when a ladder is laying on the wall, okay, so how the normal force from the wall will change as there is a frictional force comes into the discussion. Okay, so that is the additional thing I will add on. Okay, so as I discussed in the class, okay, coming Wednesday, so that will basically cover up for the chapter. Any questions, students? Okay, so if you have no questions, so then we will end the session here, because I mean nothing for me to drag further. Okay, so what I want to complete, so I've done. So next is we just need to discuss more questions on that, and I need to introduce some of the critical things. Okay, so for you to think, because that are a common critical areas where exam questions will be kind of sometimes focused. Okay, so with that, thank you and have a great weekend. Take care. Bye bye.